Today's video, we're going to go over what titrations are, and then we'll actually perform a titration as well. A titration is basically a laboratory procedure used to determine the concentration of a sample where you know it contains something and you don't know how much of it contains. In this one, we're going to do an acid-base titration where we're going to look at vinegar, and vinegar contains acetic acid, but we want to determine what that molarity is for acetic acid. So what we can do is we can use sodium hydroxide with a known concentration, and we can add that to the vinegar. And what we're going to do is we're going to add an acid-base indicator called phenolphthalein, which changes color once it reaches a basic pH. So the reason we can do that is, at first this is an acidic solution, meaning it has a pH less than 7. In that situation, the phenolphthalein is clear. Once we add the base, it's going to neutralize the acid according to this reaction. So we have acetic acid plus sodium hydroxide producing water and sodium acetate, a neutral solution. As we're adding it, the solution will stay clear. You'll see little build up of basic components, but then once we swirl it, it should go away. Once we neutralize all of the acetic acid in the vinegar, what's going to happen is there's no more acid in the solution to neutralize the base that's being added. So any additional base that gets added past that point is going to convert the solution to being a pH above 7, in which case the phenolphthalein is going to turn bright pink, letting us know that we've neutralized all the acid. Knowing that, since we have the molarity, and we'll be able to determine the number of liters of solution of sodium hydroxide we use, we can determine the number of moles of sodium hydroxide we use. If we know the moles of sodium hydroxide, and we know that it's a 1-to-1 stoichiometric ratio with the acetic acid, we can determine how many moles of the acetic acid were in the vinegar solution. Then, knowing the volume and knowing the number of moles of acetic acid present, we can determine the molarity of acetic acid in vinegar. The first thing we're going to do is we're going to fill the burette, which is this piece of equipment right here, with sodium hydroxide. So we're going to load that. Normally, you would want to line the burette, which is essentially coat the inner components of it, the inner layer of it, with the sodium hydroxide or the solution that you're placing in there. But that's something you would typically only do if it's wet or if you know it's been used before for something else. This I know is nice and perfectly clean, so I'm just going to load the burette with sodium hydroxide. So, first step, make sure the stopcock right here, this valve right here, is closed, so that way I don't just start pouring base in and it starts flowing all over the ring stand. So now I'm going to lower it to the floor. You're going to use a funnel to fill it, and then we're going to slowly, carefully add the base. The reason we put it on the floor is if you're doing this overhead and you start something breaks or something starts spilling, you don't want base just pouring all over you. That would be bad. So we put it on the floor so we can have better control of it and make it just a safer endeavor. Alright, so stopcock is closed. I'm going to hold this funnel just slightly above the edge. If it sits like this, what can happen is you get a buildup of pressure, and then the base will pool in the funnel, which can lead to it overflowing and making a mess. So I'm going to hold it there just so the air can vent and pressure does not build up. I'm only going to fill this thing up part way, but it's important that you do not overflow. And you don't have to fill it exactly to the 0 mark, because what we're looking for is the change in volume, because that's going to be how much volume of sodium hydroxide will be dispensed. So at this point, I'm going to place the sodium hydroxide solution and burette up here. I've measured out 10 milliliters of the acetic acid. I'm going to add that to this Erlenmeyer flask. Pause. Now I'm going to add a drop of phenolphthalein to the solution. And this is the acid-base indicator again that remains clear in an acidic solution, as you'll see here. 3 drops is sufficient. And then it will turn pink when I put it in the basic solution. Before performing the actual titration, I just want to bleed out this air gap that's right here within the stopcock. So I'm going to use a separate waste beaker and just get that out so that there's no air in here, so that as this volume is lowering, all of the liquid is being distributed into your acid solution. Alright, so now we're ready to perform our titration, and I've recorded an initial volume in the burette of 16.3 milliliters. And something to just point out is the top reading on this burette is 0, even when it's filled and is loaded with 50 milliliters. So it counts down. So my volume is going to increase, but really I'm just looking at the difference between the two levels. So now I'm going to add it, and when I add the base to the acid, I'm going to do so by briefly turning the stopcock and letting a little bit pour in and stopping it. Once I start to see some pink come into the solution, I'll swirl it until it goes away. I'm going to do this until the solution retains that, just slightly retains that pink color, and then we will have completed the titration. So right now I'm going to go ahead, and this will take a little while, so I'm just going to skip ahead till I know we're getting close to our end point of the titration, and then we'll resume. Ready? Okay. Now we're going to continue adding the sodium hydroxide, and we've started to see that the pink color is appearing and persisting for a little bit, but as I swirl it, it goes away. Now, you can have a mechanical or a magnetic stirring rod, and then you don't have to continually twirl it as the solution will be mixed. The reason that you get this persisting pink color that's localized is in that before the fluid mixes, you have a buildup of basic or hydroxide ions in those regions until they all mix and the acetic acid molecules can neutralize those. And you can see that the color is going to persist longer and longer until we get to our end point. Ideally, we would like it so that we don't add much more base than we need so that we can get the most accurate data possible. Yep, almost there. Probably just a couple little more additions. Each addition is, the term for it is called an aliquot. Almost. It's teasing me. And there we go. I think I slightly overshot it there, but you can see that now that the solution is basic, it is a deep pink color. It should be a slightly pink color. The final reading of our burette volume was 28.71 milliliters. We can see that we used 12.40 milliliters of the basic solution, which has a 0.8 molarity. So, knowing that molarity, knowing this volume, converting it to liters, because molarity is moles per liter, 0.01240 liters times 0.8 moles of sodium hydroxide per liter tells you that we used 0.0092 moles of sodium hydroxide to neutralize the acetic acid. So, since it was a 1-to-1 ratio, that means that there were the same number of moles of acetic acid present. Then, knowing that the molarity, since that's what we were trying to find, is the molarity of the acetic acid in vinegar, we use that number of moles and divide by the initial volume of the vinegar solution. Since we added 10 milliliters of vinegar solution, that's 0.010 liters, and we have a molarity of 0.992 molar acetic acid solution. So we were able to use a solution with a known concentration that we knew would react with something where we didn't know the concentration in order to determine that concentration. Now, this is an acid-base titration, and there are many, many, many types of titrations. In fact, when you take college chemistry, probably half of your labs are going to be different types of titrations. You have redox titrations, you have chelating agent titrations, all sorts of stuff, testing for different ions in solution. But they all come down to using a solution where you know the concentration to react with one where you don't in order to determine that molarity.